Okay, welcome Eden Prairie chemistry students. This is going to be a video on how to do mole conversions. I want to bring you to something that you should have seen on my mole and mole conversion page. That is an important concept, is that a mole is a counting unit. Just like we have a dozen means 12 things. If I say a baker's dozen, you know that that means 13 things. 1 mole of things is this really huge number, and I know you've watched a couple videos on that, so this is this isn't something new to you, but this is something that you should know. You should know this definition and memorize it, that 1 mole is equal to 6.022 times 10 to the 23rd things. And we call this number Avogadro's number, just like we would call 12 things a dozen. You know, when you have 6.022 times 10 to the 23rd things, you have an Avogadro's number of substances, okay, of things, I should say. Okay, so you also should have seen a portion of this mole map on the lesson page, and I asked you guys to write this down because this is an important thing to memorize. The two big things you would have to memorize are the things that are in blue here. 1 mole is equal to 6.022 times 10 to the 23rd things. And also, you would have to memorize what the molar mass means on the periodic table. And molar mass for you guys may be a new term for you. So let's take a look at your yellow periodic table that you had gotten from me in class. I believe the day before in lecture we were talking about atomic mass, and remember the atomic mass is the weighted average of all the isotopes of that type of element. Well, that also can be called the molar mass. So the atomic mass and the molar mass are the same things. The difference is that atomic mass has a unit of something called an AMU, and a molar mass has a unit of something called grams per mole. I typically use the term molar mass more than I would use atomic mass because it's also going to work when we have compounds, which will be happening later on in a different chapter. In this chapter, we're pretty much only looking at elements on the periodic table. So if you take a look at barium, which is Ba here, and there's this number down here. So that number is the molar mass of barium. So what does that mean? That means that 137.3 grams of barium will equal 1 mole. Or you could say that I would have 6.022 times 10 to the 23rd atoms of barium when it weighs 137.3 grams. Now, what's unique is that elements have unique molar masses. So if you were to look at zinc right here, okay, zinc is Zn. If we were to look at the molar mass of zinc, it is 65.38 grams is equal to 1 mole of zinc. So it does depend upon what element you're talking about, what the molar mass is. And you notice how I wrote this as an equivalent? That's going to be important when we start doing mole conversions, okay, which is right here. All right, so if you were asked to do a mole conversion, here's an example problem. It says, what is the mass in grams of 3.50 moles of the element copper? Well, you know, first thing you want to know is first start with what is given and look at where you want to go. So you look at what was given. You were given 3.5 moles of copper, and you want to get to grams. So you were given moles and you want to get to grams. And so what you're thinking, hopefully, is that what's the relationship between moles and grams? You're going to look back at this mole map and say, oh, I got to look at my periodic table and find the molar mass of that given element. Okay? So what you would do then is you would start out with what you know, which is 3.50 moles of copper. Okay, and I'm looking at this tile, and I do recognize that this molar mass is slightly different than the molar mass that's on your yellow periodic table, and that's okay. You're going to see things like that. I could go with, you could put 63.546, you could put 63.55. You'll just recognize that they just went to another order of magnitude on this tile on the periodic table. But what you should recall is that we can get between grams and moles by using the periodic table. And you should then recognize that the molar mass of copper is 63.55 grams per mole, which means 63.55 grams per mole, or 63.55 grams equals 1 mole. So I want you to go back to that idea of when we were doing work with dimensional analysis with the gizmo. Remember, there were two ways you could write this equivalence. You could either write it as 1 mole over 63.55, or you could write 63.55 over 1 mole. Which orientation would you want to use in this analysis? Okay, well, hopefully you're recognizing that the orientation that you want to use is this. Okay, and that's because the moles will cancel. I'm not going to make you write these two tiles out. You don't have to show me the two ways you do the equivalence every time you do a molar mass or a mole conversion problem. I'm really okay with you just working in this realm, but what you do have to do is show dimensional analysis. So you have to show that moles will cancel, so that's why I picked this orientation. And so now what I am ready to do is I'm ready to solve. And so since moles will cancel and I solve this, I punch really in my calculator 3.50 times 63.55. I get a number. I will divide by whatever's in the denominator. In this case, it's 1. And my calculator punches out 222.425 grams. Okay? Now, that's what your calculator says. You can't put all of those numbers down. And that's because here you have 3 significant figures. So you have to report this number in 3 significant figures. And the number then that you should report is 222 grams. And you're going to put a box around it because it's your answer. Some people, some of you out there might be saying, hey, wait a minute, Mrs. Snyder, I don't understand this. See that 1 mole? Doesn't that mean that there's only 1 significant digit? And the answer is no. There are no significant digits in here. Actually, you could consider them to be an infinite number of significant figures in this equivalence because this is a constant. It is like pi. It is like the speed of light. It is not used to evaluate the number of significant digits when you are doing mole conversion problems. So again, you don't look at that molar mass to determine the number of significant digits because it's a constant. You only look at what you started with or basically what you were measuring. In this case, it was 3.50. Okay? All right, well, what if we had something like aluminum? And it says a chemist produced 11.9 grams of aluminum. How many moles of aluminum were produced? Well, let's think here. We're given grams. We're given actually 11.9 grams. So we're given grams and we want to go to moles. What's the relationship to get between grams and moles? Okay, hopefully, if you don't know that yet, you're going back to your notes to where you had this mole map and you're saying, oh, between grams and moles, I got to look at my molar mass on my periodic table. Okay. I'm going to start out with what I know, which is 11.9 grams. Okay? Something has to go on the bottom. Let's see. On my periodic table, it says the molar mass is 26.98 grams per mole. So let's see, that's 26.98 grams is equal to 1 mole. That's what that means. So something has to go on the bottom and something has to go on the top. Hopefully you're recognizing that the 26.98 grams should go on the bottom and 1 mole will go on the top. Grams cancel. We are then at a unit of moles and your calculator punches out I'll put a 0 in front here, 0.441067, da 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 da. Can I report all of these numbers? No, because they're not significant. I have 3 sig figs in my number here. I don't analyze any of this because it's a constant, and so then I will report 0.44, oh, that's a 0, so make sure you know that, 1, and that unit is moles. So there's my answer. So pretty easy, wouldn't you agree? What happens if we were given something like atoms of silver and we were asked to go to moles? Well, now it's a different relationship, and this is a relationship that you should memorize. 1 mole of any substance, it doesn't matter what the identity of that substance is, 1 mole of any substance is equal to 6.022 times 10 to the 23rd things. Okay? So what I'm going to do here is I know that 1 mole is equal to 6.022 times 10 to the 23rd things. I'm going to start out with what I know, which is 4.71 times 10 to the 23rd atoms. I am then going to have to put atoms in the bottom. How many atoms do I have? Well, atoms are one of those things. So I'm going to put this big number, 6.022 times 10 to the 23rd atoms, and that's going to equal 1 mole. Atoms will cancel. I'm going to have a unit of moles, which is what I'm asked for in the problem, so that's cool. I'm going to remind you guys, when you're doing scientific notation, I recommend using the engineering notation, which is EE. And when I do this work, this is what my calculator spits out, which is 0.78213, and then there's a whole bunch. Can I report all of these numbers? No, I can't, because there's only 3 sig figs here. I have to report 3 sig figs. So my answer is 0.782, and the unit is moles. And I box it. Okay, great. All right, here I've got a problem that says that I've got 3.2 moles of carbon. How many atoms are in there? I'm going to have you guys hit pause right now, and I'd like for you to try this. When you're done, you check and see how I put it together. Hit pause. Okay, welcome back. Does yours look like this? Did you put moles in the bottom and atoms on top? Because that's the way that they should be, because the moles will cancel. Also, did you only report 2 significant figures? Because there's only 2 sig figs here as well. Okay, we're going to do one final problem, and this problem is unique because it's asking you what is the mass in grams of 1.200 times 10 to the 8 copper atoms. And when we look at this, I'm going to make this a little bit bigger here, and I'm going to try to get this done in a short period of time here because I'm running out of time. Do you notice that there is no way that you can go just between grams and atoms? The only way you can go is start with atoms, you're going to have to go to moles, and then you're going to have to go to grams. Okay, so hit pause and let's see how you set this up, and then you can check my work at the end. Okay, are you showing your dimensional analysis like this that I have below? Notice that you can't go right from atoms to grams. So you can't do this. This would be impossible to do. So you can't do this. We should actually just erase all this because you can't do that. You would have to go between atoms to moles and then from moles to grams. Each one of these equivalences is important. You cannot make the moles and just, say, well, these will cancel. So I'm going to put 6.022 times 10 to the 23rd atoms and put 63.55 grams. Don't do that. I want to see your dimensional analysis work to look exactly like this, okay? Also, because that's going to help you when we get to stoichiometry. Also, how many sig figs do you see here? Notice how there's 4. Notice how I report 4.